negative 1. So let's take a look at what that's going to look like. So for instance, if you had something like a complex number like 5 plus 3i, and let's say you're multiplying it by 4 minus 2i, just like when you had x's instead of i's, you're going to FOIL this. So you end up with 5 times 4, which is 20, 5 times negative 2i, which is negative 10i, 3i times 4, which is 12i, and 3i times negative 2i is negative 6i squared. Notice that when you multiplied, you ended up with an I squared showing up. That I squared is going to get replaced with a negative 1. So over here, you actually have negative 6 times negative 1, which is a positive 6. So you're going to have more like terms when you're dealing with the imaginary numbers in your thing that you're foiling. So when we have one complex number times another one, you're going to end up with more like terms because the I squared is going to turn into negative 1. Now if we combine like terms, 20 is going to combine with this 6 to get you a 26. And then you can combine the negative 10i with the 12i, which is a positive 2i. And this would be where you'd leave your answer. What about dividing? Now, when you're dividing, there's going to be a particular product or a particular answer to something that you're multiplying that's going to be helpful. So let's take a look at a particular multiplication problem which will help us with our dividing. What if I had 2 minus 3i and I'm multiplying it by 2 plus 3i? Notice that if these were x's, we would have called this a difference of squares, because it is. The only difference between the two binomials is one has a plus and one has a minus. So watch what happens when we multiply them. We get 2 times 2, which is 4, and then 2 times 3i gives us a 6i. And because this one has a negative, when you do negative 3i times 2i, you get a negative 6i, and the middle terms cancel. And then negative 3i times positive 3i is a negative 9i squared. And since we're able to take this I squared and change it into negative 1, over here we end up with 9 times negative 1, which turns into a positive 9. So we really only have 4 plus 9, which gives us 13. Notice all the i's disappeared. And that is going to be very helpful for us when we divide, because our division problems are going to look like fractions, and you can't have an imaginary number in the denominator of your fractions. These two things up here, because they're both identical except for one's a plus and one's a minus, are called conjugates. So what we do is we multiply by the conjugate, which is the same binomial with the opposite sign in the middle, in order to make our i's disappear in the denominator if we have a binomial in the denominator. Let's take a look at two kinds of fractions that we might have to simplify that are technically division problems. So for instance, we might just have 5 plus 3i over 2i. Notice this does not have a binomial in the bottom, so we're not going to have to use the conjugates. However, you cannot leave the I in the denominator. So what we're going to do is try and make that I disappear. And the way we're going to do that is turn it into an I squared, which we can do by multiplying both the top and the bottom by I. When we multiply the numerator up here by I, we're going to make sure that we distribute it all the way across. And that's going to give us 5i plus 3i squared. And again, we're going to change this I squared into negative 1. So what we have here is we really have 3 times negative 1. In the denominator, we have 2 times I squared. And again, this I squared is going to change into negative 1. So we really have 2 times negative 1 in the denominator. What this simplifies into is 5i minus 3, since 3 times negative 1, over negative 2, because of 2 times negative 2. Now, this is not how we want to keep our answer. Complex numbers are in the form of a plus bi. So we need to change this into that form. We need the real number portion first and the imaginary portion second. And so we don't want the 2 underneath all of it. We want to distribute the 2 so that it's under each of these separately, and we have 2 separate fractions. So I'm going to do the real portion first. The real portion would be the negative 3 over the negative 2, which ends up being a positive 3/2. And that takes care of that portion. And then I'm going to take and deal with putting the negative 2 under the 5i. And we normally write the I off to the side and the fraction out front, so that's actually going to be a negative 5/2 I. This would be the proper way to leave this so that it looks like a regular complex number. Now that one didn't have a binomial in the denominator. Let's look at one that does. So for one that does, it might look like this one. Let's say we have 3 minus 4i, and that's being divided by 2 minus I. If we just multiply the denominator by I, what would happen is this I here will turn into an I squared, which is good because we can get rid of our I, but then this would have an I attached to it. So we really don't get rid of the I when you multiply this whole thing by just I. So instead what we do is we use our difference of squares pattern and we multiply by the conjugate. And the conjugate of this 2 minus I is 2 plus I. So we multiply the top and the bottom by 2 plus I. Now, to keep yourself organized, what I would suggest is doing the numerator and the denominator separate off to the side. So let's go ahead and first do our numerator, because we're going to have to FOIL this, and there's a lot going on there. So let's distribute the 3. 3 times 2 is 6. 3 times I becomes 3i. Negative 4i times 2 is negative 8i. And negative 4i times I is negative 4i squared. Now this I squared here is going to turn into a negative 1. So when we do negative 4 times negative 1, we get positive 4, which then can be added to our like term up here of 6 to get 10. And then we're also going to combine the like terms that have an I attached to them. So 3i and negative 8i is negative 5i. So that's going to turn into our numerator. We're going to have a 10 minus 5i up here. Now let's go ahead and take care of the denominator. The denominator is 2 minus I times 2 plus I. And so when we distribute that, 2 times 2 is 4. 2 times I will be a 2i. Negative I times 2 is negative 2i. Notice these cancel, which is good, because that's what we wanted to happen. And then negative I times I is negative I squared. This I squared is going to turn into a negative 1, so we really have 4 and then this minus here, negative 1. Our double negative makes a positive, so this becomes 5. So the denominator is 5. Now we don't want to leave it so we have a binomial over this single 5. So we divide the 5 into each item separately. And 10 divided by 5 is 2. And then 5 divided by 5 is 1, so we get a minus I. So this ends up being our solution to simplifying this particular problem.